In this video, you're going to learn physical quantities, units and measurements, a chapter of IGCSE O-level physics. You will be able to accomplish a firm grip on the concepts related to physical quantities, units and measurements. I am an experienced online physics tutor and I have done thorough research on these concepts of IGCSE Physics. So, let's begin. Physical quantities, units and measurements, our first chapter of O-level physics. So, firstly, we'll start off with defining scalar. Here, scalar means scalar quantities. In physics, there are two types of quantities, scalar quantities and vector quantities. First of all, we will define what are the scalar quantities. A physical quantity which has some magnitude but no direction. It is such a physical quantity which has some magnitude but it has no direction. So such quantities are scalar quantities. For example, length. We can measure the length. Let's suppose we can say that the length is 5 centimeter, 10 centimeter, 15 centimeter, but we cannot determine what is the direction of the length. So length is a scalar quantity. Next is mass. We can measure the mass but we cannot determine its direction. We can say the mass of an object is like 5 kg, 10 kg or 15 kg, but we cannot determine its direction. So mass is also a scalar quantity. Another scalar quantity is time. Okay, so time is another scalar quantity. We can say the time is you have like 10 seconds to do this task or you have 15 seconds to do this task, but we cannot determine the direction of the time, where the time is going. So time is also a scalar quantity. Next, vector quantities. Vector quantities are such which have both magnitude as well as direction. So a physical quantity if you are not understanding my writing, then just do comment in the video and I'll try to improve it. A physical quantity which has both magnitude as well as direction is a vector quantity. Okay, so such a quantity which has both magnitude and direction is a vector quantity. For example, velocity, it has both magnitude. We can say the velocity of an object is 10 meter per second, 20 meter per second, 30 meter per second. Moreover, it has direction. We can say an object is moving towards east, towards west, towards north or south. So velocity is a vector quantity. Next, displacement. Displacement is also a vector quantity because let's suppose there are 2 points, point A, point B. You can say object has moved from A to B. What is its displacement? So there is particular direction from A to B. so it has both magnitude as well as some certain direction. So we can say the displacement between A and B is, let's suppose, 10 meter, and direction is heading towards B from A. So this is the example of a vector quantity. If you have any more vector quantities in your mind, just do comment in the video. After this, we will switch on to the concept of so now we will discuss the addition of vector by graphical method. The second concept in this chapter, the addition, or you can say subtraction of vectors by graphical method. Let's suppose there is a vector A and there is a vector B. If we have to add these two vectors, the answer will be a third vector, and we can say the third vector is R. So we can say R is equal to A plus B. So the answer of the addition of A and B will be R. So how we will add these two vectors? Just draw vector A over here, and the tail of vector B will be joined with the head of vector A. So we will just pick this vector and put it here like this. So the head of first vector is connected with the tail of the second vector. So the resultant will be, the tail of the resultant vector will be joined with the tail of the first vector, and the head of the resultant vector will be joined with the head of the second vector. So this will be the vector R. In this way we can add two vectors graphically. Now what if these two vectors A and B are same, and we have to find our resultant vector R, that is equal to A minus B. So what will we do now here? A will remain like this, and we can write this equation as A plus minus B. So in order to draw minus B, we will just switch the direction of vector B. So the direction of vector B initially was like here, the arrow was here, the minus B will be like this. Whenever you have to determine the negative of a vector, we will just invert the direction of the vectors. Okay, so the tail of this vector will be joined with the head of this vector. So vector A over here, vector B over here. So the resultant is like this. This will be the resultant vector. Okay, so this was our second example, this was our first example. Now let's discuss another case. Let's suppose we have to find R is equal to 2A plus 3B. A and B are the same vectors, like this, A, B. So we have to find 2A plus 3B. So first of all we have to draw vector 2A. So if a vector is being multiplied by a number, we'll just multiply the length of that vector. So vector A will be like converted into 2a, and vector b will be like 3 times of its original size, so this will be 3b. So r is equal to 2a plus 3b. So I draw over here, this is 2a. Now I'll just place the tail of vector 3b on the head of vector 2a, so it will be like this. This is vector 3b. Now the resultant will be like this. Over here, this is the resultant. So r will be equal to 2a plus 3b. If you have any query regarding the addition or subtraction of the vectors by the graphical method, just comment below in the video. Okay. Now I'm going to write some physical quantities, and we have to differentiate between the scalar quantity and the vector quantity. So I'm going to write some physical quantities: distance, displacement, length, speed, velocity, time, acceleration, mass, and force. So I have written down some physical quantities over here, and I'll tell you from among these physical quantities which are vectors and which are scalar quantities. So first of all, distance. We can measure the magnitude of distance, but we cannot determine the direction of the distance. Distance is any length, 1 meter, 10 meter, 15 meter. So distance is a scalar quantity. I'll write S for the scalar. Next, displacement. As I told earlier in my lecture that displacement is related to direction. If there is a point A over here, B over here, object moves from A to B, this object will follow some path, some direction from A headed towards B. So this displacement has some length as well as some direction. So this displacement is a vector quantity. Next, length. Length and distance are almost same. Okay, so but length does not have any direction, so length is also a scalar quantity. Now speed. Speed is time rate of change of distance is speed. Like speed is equal to distance over time. So distance is a scalar quantity, time is also a scalar quantity. So speed will also be a scalar quantity. Next, velocity. The definition of velocity is displacement over time. Rate of change of displacement is basically velocity. As displacement is vector, so velocity will also be a vector quantity. I'll tell you a formula to determine whether a quantity is scalar or vector after sorting out these physical quantities. Okay. Next is time. Time has no direction, but it has magnitude, so time is a scalar quantity. Acceleration. Acceleration has distance, acceleration has direction as well as magnitude. So acceleration is also a vector quantity. Mass has a magnitude, some particular magnitude, but no direction. So mass is a scalar quantity. Okay, and last but not the least, force is a vector quantity. Now, how I have determined the acceleration is vector, or force is vector, or velocity is vector, I'll tell you in this step now. Let's suppose I'll write down the formula of velocity first. Velocity is equal to displacement divided by time. So we know that displacement is a vector quantity. So vector time is a scalar quantity divided by scalar. So vector over scalar is vector. If in the numerator there would be vector and in the denominator there will also be a vector, then it would be scalar. So when a scalar and a vector is multiplied or divided, the answer is a vector quantity. If a scalar is multiplied with another scalar, the answer is a scalar quantity. Multiplication or division is the same thing, okay? And if vector is multiplied or divided by another vector quantity, the answer will also be a scalar. So this formula is very important in order to determine either a quantity is a vector quantity or a scalar quantity. Let's suppose in force is equal to mass into acceleration. Over here, mass is a scalar quantity, acceleration is a vector quantity. So scalar is being multiplied with a vector, so answer is a vector quantity. So force is a vector quantity. Okay, so by using this technique or this formula, you can say you can determine whether a quantity is scalar or vector. Okay, so now we will describe how we can measure a variety of lengths with appropriate accuracy using tapes, rules, micrometers and vernier calipers. Okay, there are some tools that are used to measure the variety of lengths. Here I can write over here: measuring tapes, rules, micrometers and calipers, or we can say vernier calipers. Okay, these all tools are used to measure the lengths, but if we have to, I'll write down here 4 types of lengths. Okay, 12 meter, 0.5 meter, or I can write it as 50 centimeter, and 4.7 centimeter, or I can write it as like 4.8 millimeters. So 1, 2, 3, 4. There are these 4 types of lengths. Now this 12 meter length, I cannot measure 12 meter by a vernier caliper, micrometer or a meter rule. any length larger than 1 meter, I can measure it with the measuring tape, because the length of measuring tape is like more than 1 meter. Now the length of 50 centimeter, I can measure this length of 50 centimeter by using tape as well as meter rule. But the most convenient instrument to measure 50 centimeter of length is meter rule. So I will use meter rule to measure the length of 50 centimeter. Next, 4.7 centimeters. Now this length I can measure by using a vernier caliper, because the vernier caliper can measure length up to 0.01 centimeters. So if any object has length, let's suppose 4.72 centimeters, vernier caliper can measure it, but meter rule or measuring tape cannot measure it. So this 0.01 centimeter is the precision of the measuring instrument. So the precision of the vernier caliper is 0.01 centimeter. Now what about this length? It is 4.8 millimeter. We cannot determine this length by using a measuring tape, meter rule or a vernier caliper. For this purpose we have to use micrometer screw gauge, okay, or simple micrometer, because the precision of micrometer is 0.01 millimeter. A micrometer can measure any length up to 2 decimal places in millimeters. So the precision of micrometer is 0.01 millimeter. So this length of 4.8 millimeter can be easily measured by micrometer screw gauge. If you have any issue regarding this concept, then just do comment in the video. Now this was about measuring the lengths. Now I will tell about the methods of measurement of time intervals. How we can measure time. How to measure time intervals. So in order to measure time intervals, we have two main instruments, clock and stopwatch. Same is the case over here. If we have to measure time in hours or in minutes, then clock is a suitable option. But if we have to measure time in seconds, for short intervals, then stopwatch is more suitable. Let's suppose we have to measure the time of a journey from one city to another, so it will be obviously in hours and minutes. So clock is more suitable option for that. Moreover, we have to find out the time in order to time for 100-meter race, okay, or 100-meter lap. So stopwatch will be more suitable. So you can use stopwatch to measure time for short intervals and you can use clock to measure time for longer time intervals. So in this way you can use these instruments to measure the time. Now one more thing, if you need more accuracy in measuring time, then you can run the experiment for 3 to 5 times and note down the readings. Let's suppose an athlete covers a lap of 100 meters in 18 seconds. Okay, you run the experiment for you have to find out the average time of this athlete to cover the lap of 100 meters. So in first experiment it completes in 18 seconds, then in 19 seconds, then in 20 seconds, then again in 18 seconds. Then you can just take the average of these four numbers, okay, and calculate an average value. Okay, similarly, if you want to know the time an object takes to fall from a certain height, so what you can do, there's a certain height over here. Let's suppose this height is of 5 meters. You throw the object from this height for 5 times. Notice the time intervals. Let's suppose the time intervals are 0.5 second, or you can say make it height as like 50 meters. Okay, so first it will be like 2 seconds, let's suppose, then 3 seconds, then 4 seconds, then 3 seconds again. So what will be, and also 4 seconds. So what will be the average time? 2 plus 3 plus 4 plus 3 plus 4 divided by 5. Whatever will be the answer, this will be the average time an object takes to fall from a height of 50 meters. So in this way you can use these time measuring instruments in order to find out the time intervals. So we are done with chapter 1 of IGCSE O-level physics, the physical quantities, units and measurements. If you have any questions, any queries, just do comment in the video below. I'll be able to answer all of your questions. Thank you.